So we're given x squared plus y squared equals 25. And hopefully you recognize that that is a circle with a center at 0, 0, radius at 5. It's okay if you didn't recognize that though. You don't need to know that to do this question. But it says find the equation of the tangent line at the point 3, negative 4. And so we want to use implicit differentiation and take the derivative of both sides of our equation. So just showing that we're doing something to one side, we're doing it to the other side of the equation. So the derivative of x squared, that is 2x, plus the derivative of y squared. So y is a function of x, so we have to think of this as the chain rule. So we're going to bring our power down front, 2 times y, subtract 1 from my exponent, just 1, times the derivative of the inside. So a way I can express the derivative of y, I can write it as y prime if that's easier for you guys. But we can also express it, and this is how your book does it, dy dx. And this is equal to derivative of 25, which is 0. So in order to find the equation of the tangent line, we need the slope. And so we want to find dy dx first. And that's just the derivative anywhere that our function is defined. And the derivative exists. So let's subtract 2x on both sides. So we get 2y times dy dx is equal to negative 2x. Divide both sides by y, we get dy dx. Let's divide both sides by 2y. We get is negative 2x all over 2y. Our 2's cancel, and so we get the derivative is equal to negative x over y. So we know the slope of our tangent line is equal to, well, we need to plug in our values. So we know what x is, 3. So if we plug in 3 for x, we would have negative 3 all over, and we want to plug in negative 4 for y. So slope of our tangent line at the point 3, negative 4 is equal to 3/4. Okay, so we have the slope, we have a point, and now we want to find the equation of the line. And so we can either use our point slope formula, or we can go in and we can plug in our y value, which is negative 4, is equal to our slope 3/4 times our x value, which is 3, plus b, solving for b. So I have negative 4 equals, well, this is 9/4. Let's subtract 9/4 on both sides. Plus b, or equals b. Need a common denominator, which is 4. So I have negative 16/4 minus 9/4. That's negative 25/4. So I got b is negative 25/4. So my equation of my tangent line is y equals my slope, 3/4, times x, and then plus b, which is negative 25/4. That to me didn't look like a 5. So that's the equation of our tangent line at that point, 3, negative 4 on the curve x squared plus y squared equals 25. Notice if we had plugged in the value of x equals 3, we would have had two separate values for our point that would give us different y values because this is a circle, right? So if you plug in 3, you get 9. Subtract 9 on both sides, you get y squared equals 25 minus 9 is 16. Take the square root of both sides, you get that plus or minus 4. So this would be the one below the x-axis. Okay, for that x value. So if it asked us to find the equation of the normal line to the curve at 3, -4, the normal line is just the perpendicular line to the tangent line. To the tangent line in our case at 3, -4. And so if I was looking at this, I know that the slope of my normal line, if it's perpendicular, I'm just going to say norm. This is equal to the negative reciprocal of my tangent line. So flipping it, I get -4/3. And so again, I have a point and I have a slope. And so I could figure out what B is to figure out what the equation of my normal line is. So that would be -4 equals -4/3 all times x, which is 3, plus B. So -4 equals -12/3. Oops, that's nice, right? 3's cancel. Let's just do that. So that's -4 plus B. Add B, 4 to both sides to get B by itself. So we get B is equal to 0. And so the equation of the normal line is equal to my slope, -4/3 times x, plus, I don't have to write 0. I'm just going to say y equals. That norm looks kind of funny. Okay. So just extending what we were just talking about and looking at that circle and finding the second derivative just anywhere, not just at a particular value. So there's two ways that we can do that. We can look at what dy dx was. And if we do look at this and take the derivative again, then we're going to need to use the quotient rule. Or, and I'm not sure if this is easy or not, we can leave it how we have it right here, where we have 2x plus 2y equals dy dx equals 0. And then let's just take the derivative again. So let me just write out, I'm going to take the derivative again of both sides of my equation. And so when I take the derivative of the left-hand side, derivative of 2x, that's not too bad. That's just 2. The derivative, though, of this second grouping inside that bracket, I'm going to need to use the product rule. Use product. And so I'm going to have plus. So let's think of maybe 2y as our first function. So the derivative of 2y, so derivative of 2y is just 2. But y is a function of x, so I need to write times the derivative of the inside, dy dx. This is a little confusing too, times dy dx. This is equal to, not equal to, sorry, that I'm not done with that. Plus, okay, so let's look at product rule. So times the first function, 2y, times the derivative of this second function. So derivative of dy dx, that is can rewrite that as d squared y over dx squared. Is equal to the derivative of 0. Well, derivative of 0 remains 0. In this case, we wanted to solve for d squared y over dx squared. And so we want to keep that by itself. I just want you to see this really quickly. There's a difference over here in this piece. So let's just rewrite this. This is 2 plus 2. The derivative of y with respect to x times the derivative of y with respect to x, that's like that quantity squared. It's like the derivative quantity squared, which is different than the second derivative. So this would be dy dx quantity squared plus 2y, and then we're solving for this d squared y over dx squared, second derivative. And so we want to get this piece by itself. And so we could subtract 2, and we could subtract 2 times the derivative of y quantity squared to both sides. So subtracting 2 times.
Isn't it 2y, not just 2 in the third term?
Yeah, 2y. Let's just look at this. Yes. So bring down our y, bring down our y, bring down our y, which would have been right here. Thank you. And this was quantity squared. So we can get our second derivative by itself by dividing both sides by 2y. I think the way I might have done it might be a little bit harder. Let's factor out the -2 from both of those terms. And so we have 1 plus dy dx quantity squared all over, we're dividing both sides by 2y. So notice our 2's cancel. Oops. I can think of it as distributing my -1. And so we have the second derivative of our function y with respect to x. This is equal to -1 minus the first derivative, quantity squared, all over y. Okay, here's where, let me read those directions again. Write the solution in terms of x and y only. So it doesn't want this dy dx in this solution set. So we need to look at what dy dx was. Look it up here. We said that dy dx was -x over y. And so we're going to want to go in there and we're going to want to plug in -x over y wherever we see that dy dx. So we get the second derivative of y with respect to x is equal to -1 minus dy dx, which is -x over y, quantity squared, all over y. And so my guess is the homework is not going to like you to put this in as your solution because we have a complex fraction. And we can clean this up. And so we have -1 minus, well, negative xy times negative xy, that's positive x squared y over y squared, all over y. I tend to like to get rid of my complex fractions by multiplying by my LCD of all the fractions within that main fraction, using that as a fancy one. So multiply both top and bottom by y squared over y squared, or just y squared. And so doing that, we got to distribute that. So we get -1 times y squared is y squared minus x squared over y squared times y squared cancels, so just x squared, all over y times y squared, which is y cubed. So I don't know if that was actually easier than taking that and not using the quotient rule. But if we use the quotient rule on that to take the second derivative, we should get this same thing back. Happy to go do that if anybody wants to see it. Let me just pause to see. So notice that I dropped my little negative again. I have this negative in front of my 1, distributed it to -1, so this should be -y squared minus x squared.